Hey Runar, how you doing today?
Great, Paul. How are you?
Very good. I am excited about what we're going to work on. I have a fun little project for us. So, as you may have heard, we are building this distributed event processing library. Fabio's doing all the heavy lifting of the core engine, but I thought it would be fun to implement some uh, just combinators and helper functions for different kinds of streaming calculations. And so the cool thing is that the way that you define new calculations is very high level, and we're just going to be writing pure functions that we can easily test locally, independent of the big distributed system that you would be able to apply these to. So yeah, I think it'll be just like fun functional programming, writing combinators kind of stuff. And you ready?
Totes.
All right. So let me give you just a quick tour of the core type that we're going to be working with. And then we
That'll be
can
useful for
start
me.
writing some code. Yeah, so let me share screen. I'm going to share. I'm just going to share my entire screen. Okay. All right. So can you see my Firefox window here?
Yeah,
Okay. All right. So here is the type. Um, Ignore the definition for a minute. Let's just focus on the shape of the type. So XF, by the way, is short for transform. Um, and so it's a transform that conceptually think of it as it's mapping from a list or really an infinite stream of ki pairs to a list of O, whatever O is. Okay? So it's a stream transformation, basically. Um, okay, the one maybe interesting aspect to it is that it has to be a causal stream function. So at any point when you are producing the output, you can only take into account um, elements that you've seen before up until that point. So you can't like look ahead into the future. Um, cool. And then
success.
the actual implementation of it is this kind of fancy continuation passing style thing that gives us fusion of lots of operations. But we're basically not going to be touching that today because that is the hard part is done, and we're just going to get to assemble new functions by using the higher level combinators. So yeah, here's like some example code of defining a transform from nat to text. We take the input, that's also sometimes called no-op or the identity transform. You can see its type is from I to I, right?
Hmm.
And then we progressively, transform that with different stages. So we can filter, we can map, we can fold, which is really a scan. It's like going to produce a running count or sum as of each element in the input. And then we map again to make some JSON. And this is just a little helper function that's useful for docs. So a doc example, you give it a list of inputs and a transform, and it produces the list of outputs. So I use that just in some of the documentation.
What's the purpose of
Um,
the input? If it's just an identity.
it's uh, sort of the starting point of the transformation. So you do need to retain the um, input type. It's like I guess you're like you're keeping the input type and as is, and then just progressively transforming the output type.
Okay.
Like if you look at the type of filter, for instance, you can see it takes in an XF. It is not
Oh, I
an
see.
XF. So it's kind of, yeah, that's sort of all the functions we'll be writing will take as some input transform, and then usually modify the output in some way.
You start with the identity transform, and you progressively add more to it.
Add more stuff to the end of it, basically.
To the end, yeah. Okay.
To make a pipeline. Okay, so that is cool. In terms of how you would use this in the stream processing library, it's basically you can apply an XF KIO to a KLog I, and you can get a KLog KO. So KLog KA is a distributed keyed log. So there's like an infinite stream for each key, and it's like this big distributed thing. And every time you apply a transform, you're implicitly operating in parallel on all of the keys. So, okay, and then there's some helper functions for, you can apply this to a list of inputs. And then lastly, this is not just for sort of linear series of transformations. You can also split the input into two paths, do transformations separately to those two paths, and then later combine them back together. So that's an example of this. So we take the same input. On one branch, we increment. On the other branch, we multiply by 1,000. This is obviously kind of a silly example. And then we bring those two branches back together with a zip. This happens to be a par zip, so it's actually going to run those two branches in parallel, which is pretty cool. If you didn't want that, you could use a regular zip. And you can see it, kind of does what you'd expect. It's incrementing the one branch, multiplying by 1,000 in the other branch, combining them together. And when you build up one of these transforms, and when you apply it to a KLog, it produces a single pipeline stage. So there's no materialized intermediate stages, even if the transform itself is like composed of 10 different stages of mapping and filtering or what have you.
Cool.
All right. Any questions so far?
Not for me.
All right. So I was thinking maybe we could just get started by writing a test for something that I did not. It was an existing function that I did not write a test for.
Okay, sounds good.
Just to kind of get our feet wet. So let's look at said function that I did not write a test for. I think I called it delay. Okay. So I didn't even have docs for it. So this is very sad. So we should fix that. But I guess what I wanted a delay to do is you give it a list, and the first, basically it's going to peel off elements from that list, sort of shift. It's basically going to shift the output over to the right by whatever the input is.
So it's going to put that list at the front of the input? Is that what that means?
It's going to put that list at the front of the output? Yeah, that's right.
Yeah.
So if you, say delayed a, well, we should come up maybe with a good example for the doc. But yeah, why don't we, let's go ahead and let's try writing the doc first, and then maybe we can add the test. So xf.delay.doc. What do we want to say about this? Well,
I mean, it puts the list at the front of the output. I think that's the most straightforward way to see it.
yeah, okay. Um, puts elms at the front of, or at the beginning of the output.
Yeah.
Of the output of XF. Shifting all the other output over. Or
Yeah.
maybe, yeah, is that any clearer?
Maybe just delaying all the other output until that list is exhausted.
Yeah. Or until LMs is exhausted. Great. All right, let's do an example. So, and this will show the example sort of syntax. So if we just say doc.example of say 1, 2, 3, 4. I think it's like that. xf.doc.example. Oh, we need to define. We need to call something here. xf.delay. Let's say delay 0. Oh, and then it takes an argument, right? So I think we'll just, how about we just delay the identity function or the identity transform? And what we would expect is that this is going to produce 0, 1, 2, 3, 4, right?
Okay.
Basically, we're just kind of consing the 0 onto the front. Okay. Display xf.delay.doc.
You can also say docs delay, and that will do the same thing.
Oh, okay. All right. Well, that did not do what we expected.
No.
So great. Why don't we go ahead and edit xf.delay, because I wouldn't be surprised if there's something
Does it have a bug?
just wrong about it. Okay. So loop. What does loop do? Let me just open up loop just so we can take a look at this. So xf.loop is sort of like the lowest level kind of, or it's a pretty low level combinator. It's like a stateful fold. You give it some initial state, you give it a function that gets the current state, the key, the output, and produces a new state and a new list of outputs. So it can both skip events and it can drop inputs. So yeah, do you see anything obvious here? It's like in the implementation of delay, we start with this. This is like the delay buffer, and then if the delay buffer is empty, okay, then we just emit the output. That's fine. If the delay buffer is non-empty, you
output the head.
Yeah, you output the head of the delay buffer, and the new state becomes the tail of the delay buffer plus the current output. Kind of seems right. Let's do some simpler ones. Let's just look at like doc.example of you know, 0, 1, 2, 3 of xf.fold 0 nat.plus.
Oh, I see. You should go 6.
Well, it's going to do the partial sums.
Oh, I see. So it's by
Oh,
0, 1, 3, 6. Okay.
there we go. Yeah,
All right. Makes sense.
that looks good. I just want to view xf stuff. I know this is defined in terms of loop.
Oh, yeah. Okay.
Okay, great. Well, help me out.
Okay, so it's telling that the bug is that it outputs 4 zeros.
That is telling.
So it's outputting whatever is in the delay 4 times. So the input is, the input is 0, 1, 2, 3.
Yeah,
Right?
let's just make sure if we change this to like 100, does it output 400s? Yes.
Yeah, 400s. So it's like it's
Great.
replacing instead of shifting.
Mm-hmm.
Yes, I'm not sure how loop is supposed to work, really. So what are K, S, and O here?
K we're not using. That's like the key for this stream. But yeah, in this case, we're just ignoring it.
Okay. And then S is what?
S is the current state. Oh my gosh, dude, I see it.
Yeah.
We're matching on by instead of on S.
Yeah, there you go.
Whoopsie. Okay. I did not follow my own advice, which is to shadow variables that you're no longer using. Well, great. That worked better. Although, yeah, okay, that makes sense.
Cool. Back to the doc.
All right, back to the doc. Great. Thanks, man. All right. Well, yeah, maybe we'll do let's do the identity function. So if you delay with the empty list, delaying with the empty list, is the identity function or the identity type access.
Mm-hmm.
Okay. So I can
One
say
thing I want you to
docs.
do is to put a heading above the examples with like examples and then explain the first example.
Sure.
That's just like a convention that we follow.
Sure. I don't know. What do you want to say here? Feel free to type away if you want to.
Oh, yeah. Forgot that I can actually type into this thing. Are we here? Oh, yeah, there. Nope. Okay. I have to unfollow you.
Oh yeah, the following gets annoying. I
Actually don't know how to do that.
if you do Command Shift P, I think you can live share, unfollow.
Unfollow participant. I got it.
Yeah. While you're doing that, I'm gonna write a test. Um, let's see. I do have a little helper function for defining tests too.
Is there anything more interesting than no op that we can put in this doc? Is it like an increment transform?
Yeah, you could do no op pipe to map nat.increment if you want.
Like this. Oops. Map increment.
Yeah. Does that work?
Yeah.
Great. Okay. Let's write some tests.
Great.
I would say,
so we already have one test, which is delaying the empty list as the identity.
Yeah. All right. So test.example. So let me just pull this up. You give it a list of input and a transform and a list of expected output, and that's it. Okay. So list of input. Let's say 1, 2, 3, and a transform of xf.delay, empty list of no op transform, and that should produce the list 1, 2, 3. Let's make this a test watch, and bada bing, passed. Okay, what else we got? Let's maybe do something.
I mean, for any given list, delaying.
Yeah.
Delay should be the same as prepend or append.
Yeah. It's prepend, but it does preserve the length, so it's not. But yeah, I get what you're saying. Yeah, let's do a property. Each repeat 25. Let's declare an input, which is whatever. Are there some helper functions for? I always just end up doing like list.replicate.
Yeah, it was like random.list of.
Oh, great. Random.list of.
I think so. Anyway, let me check.
Okay, random.list of. It takes a. Okay, great. Oh, weird completion. But I think it's just. I just do random.nat in say 0, 100. But where do I pick the size?
I usually just start by making a random nat generator first.
Go ahead.
So you say like n equals to random dot nat n 0, 100. I'm gonna say and then.
Got it. Okay. And then.
So that'll be a random list of, n elements, each of which is in n.
Yeah, let's do maybe the delay buffer could be the same.
Yeah.
Okay, and then delay. Okay, we want to just do xf dot test example of, I guess, input, and
xf dot delay
delay buffer. No op. Okay, and we're expecting this to be, it's going to be input plus, or no, it's going to be delay buffer plus input, but then a take of like a list.take of list.size input, I think. Oh, the test example already does the ensure equal.
Oh, it does. Oh, test
Yeah,
example.
yeah.
I see.
Yeah.
Okay, sorry.
Okay, I think this might do it. Does it blend? It does. Passed. Nice.
Nice.
That was suspicious. Hold on. Let's change this to, I just want to make sure this fails. We just set it to the empty list. Okay, great. Just making sure we didn't somehow, not run the test or something. All right, great. So we've got some tests, we've got some docs. Ship it. And we fixed the bug.
Fantastic.
All right. Added. Oh, sorry. Updated. Voila. Okay, great. Cool. Let's delete this from the scratch file. And let's do something a little more interesting. Maybe let's brainstorm some ideas for just different functions we could write.
Yeah, so like what's not already there, I guess is the question.
Yeah. So yeah, let's just do an xf dot. Okay. So yeah, there's count, there's delay, there's filter key, filter map, fold. Yeah, align, zip, replace missing. One thing there's
tail?
not tail.
Yeah, like skip one.
Just like skip the first element, or
yeah, something like that.
Yeah, or like skip while, or I guess drop
yeah.
while.
Take while,
Yeah,
drop while.
Yeah, the classics.
Take and drop already are, right?
Take and drop are not here.
Oh man, let's start by doing take and drop.
All right, great. Take it away, man.
Okay. So xf.take. Is this just in the namespace? Okay, it's in the namespace take. I mean xf.
Yeah.
Okay. Takes a nat and gives you an xfkio. Do the same.
Looking good. I'm gonna work on some docs.
All right.
I wonder if come on, Copilot, what do you got for me? It's thinking.
Is Copilot not working for you?
It's currently spinning beach ball of doom. All right. Too slow, Copilot. All right. Yeah, I was just seeing if it would help with the docs, but
works pretty well here. Using the VS Code. Sometimes it needs a restart. So what do I have to work with here?
Yeah, okay, great. This is actually a good example of it's stateful, right? There's some state. So you could use loop, where the state is. That's one option. Yeah, you could use loop, and just if the state is 0, then you're just going to skip all of the output.
All right. Okay, so where is this on share? Where is XF?
Let me link to it.
Oops.
How should I link this to you? I'll send you a Slack DM.
Maybe for the video, show how to where it is on share.
Yeah. But
I just search for KLogs.
Yeah, it's this project. It's a public project, systemfw/KLogs. So if I was here, it would be KLogs, bing, open that up, look at the currently buggy version of xf.delay that we just fixed. And
right. Good thing we wrote a test, huh?
Yeah, right. Pro tip, everyone: write tests for your code. It's a good idea.
All right, so xf.loop. That signature here. So it's this. Okay. It takes the initial state. And
let's just make n the initial state, and just count down to 0.
Oh yeah, that sounds good. And then it takes the k and the next n. I guess I'll shadow.
Yeah, let's not mess that up again.
And then output. Okay, and we need to return a new state. It's going to be like decrement n. I guess I'll say if n is, greater than 0, then decrement n. O? Or is it just O? No, okay, I see. How do I break? I need to return some S and some O's. Do I just do N and empty list or what?
That's it. There's no breaking. So all these transducers are infinite. You give them infinite input, and they're going to do something with that input.
I see.
So all you can do is just continue skipping elements. So this probably is, well, yeah. It might. I'm not sure how common this will be, but certainly.
It's certainly a valid use case.
Very perfectly cromulent transform. All right, I got a couple examples here. Let's do take 3. Okay. What do you think about, do all the examples need commentary, or
I mean, it doesn't cost you anything to add the commentary.
Well, it costs brain power because I'm like, what do I even say about this? Yeah, I think I'm gonna go no commentary.
You can just say that, this gives you the first three. Yeah.
All right.
It's fine if it's completely obvious. It's just another way of stating the same thing. It helps readers, see the same information in two different formats.
Yep. Um, Ceph.take.
Is that the same example?
Oh, I'm gonna
Oh, I see.
just show that, if the input. This is maybe not even relevant in a real situation because the input is infinite. But anyway, okay. I'm just going to comment you out for 1 sec. Take a look at these docs. Docs look good.
All right. Well, this test is passing, so you didn't really need to comment me out.
All right, sorry.
There you go.
Yeah. Do you want to do a property test of some sort?
Yeah, what's a property for take? The size of the output should be the same as the take, whatever. So it's like,
Yeah. You could check for consistency with list take. It's a good one.
oh yeah, that's cool. Each repeat,
Let's make a list.
25. And then I'll say list equals random dot list of well, nat in 0, 100 list of nn. And then I say ensure equal take. Oh no, wait. I do test
Yeah.
example. And no list, and it's xf dot take. Oh, I need an n. Oh, k equals random n 0, 100. This one needs to do. So take k list.
I'm going to make the K. Oh, no, this is probably
Oh,
fine. I was going to say the K could be between 0 and N, but
go up.
I think it's fine. Should behave the same regardless.
The same as that, right? Wait, this would be no up.
Yeah.
Best.
Amazing.
I mean,
right.
Want to see it fail. Does it still pass? No. Okay,
No.
great.
Yeah, we just didn't
Oh,
have to save
it was nice to see your test fail at least once.
Yeah. Great. Done. All right. Let's do take while. I don't know. What do you think? Let's pick something. Let's come up with some other ideas.
Okay.
I mean, we should definitely do take while at some point, but I wanted to do something slightly more fun.
All right. So something that isn't just like skipping a bunch of elements.
Yeah.
All right. Well, this is a nice little warm up, though.
Yeah, I'm feeling very warmed up. Um, how about like a chunking, like chunk up uh, various kinds of chunking. Maybe chunk up, 10 elements at a time, or maybe like a chunk while where you you give it a predicate, um, and as long as adjacent elements test, true with the predicate, you consider them in the same bin. You might use it to like chunk things up on, minute, combine things into like minute buckets or something.
Yeah, I like it. I think that's good.
In fact, could you even implement chunk? Well, okay. So ideas is like a chunk xf.chunk xf.chunk while. Um, Let me start with chunk. Easy enough too. So I think this is going to take a nat chunk size, and it's going to take a input. It's going to return a xf k I list above.
Yeah.
It might even be interesting. I want to play with this maybe after. I wonder if we could even pass another transform to chunk, like chunk width, such that it starts like reducing the chunk sort of as you add to it.
Oh yeah.
But let's start with the simple case. I have a feeling that's going to be harder and is going to require looking at the representation of XF and doing crazy CPS stuff. Okay.
Yeah, maybe. But like chunk could be written in terms of that.
Oh.
Or like the width is putting it in a list.
Right. Yeah. That could be okay.
But maybe that's not worth it. Maybe we just write chunk.
We'll come back to it. Maybe
we'll come back to rewriting that in terms of chunk width. It might not be worth it.
All right, so this feels like
it's like another loop.
So sure, we're gonna loop. Well, maybe just the state is the current chunk that's being accumulated. And then we're going to have K. We're going to have, oh, sorry, we're overloading K here. Let's call this chunk size. We've got our buffer that we're accumulating, and we've got our input. I'd say if our buffer is greater than or equal to chunk size, then it's really if it's equal. There's no way it's going to be greater, right?
I mean, you may as well say greater than or equal. I mean, it doesn't matter.
Okay. Then we're going to emit the buffer. We're going to reset the buffer to O. No, we're going to reset the buffer to contain O. And then we're going to emit the buffer. There's like a fence post thing that I'm not quite sure about. Like, I'm not sure. If we're off by 1 here, but otherwise we just add O to the buffer and don't emit anything yet. Does that seem right?
Yeah.
This is also quite tough check. There we go.
Well, what happens if you reach the end of, like it's going to start skipping and stuff? And you have, like, you fill the buffer, but there's like no more input. What do you get?
So there is no such thing as there's no more input. There's always more input. I mean, like, it's always a function of an infinite stream is how it's meant to be applied.
All right, but what happens in the case where you're chunking? Like, you write the test, and you do a test example with, with the window size is 4, but your input list it's
only has 3 elements. Then yeah, it would never emit anything because it hasn't accumulated a full chunk yet.
Okay. Is that what's intended?
Yes. Or I mean, well, what else could it do?
I don't know. I'm just wondering if that's the intended result.
Yeah, because there's no like end of stream signal that you can get where you can be like, oh, I just got the end of stream signal, so now I'm going to do something different.
Oh yeah.
So this is just like, eventually you'll get another element and then emit the buffer.
Right.
This is it's more of like a buffering. The interesting thing about these stream processors is like you can think of them as more of a temporal thing. It's like what this is really doing is it's going to wait until a buffer of chunk size accumulates. So it's going to have these input events. It's going to wait till that buffer accumulates, and then it's going to emit exactly that many elements as a single chunk.
I see. So what does it do? Buffers or?
Yeah, buffers outputs of.
Yeah, this accumulates outputs into a buffer of size n from xf, buffer size n. and emits them all as a list. Like, what happens here?
Did happen. Oh,
I don't know.
missing a
Did you
closing.
undo?
Maybe that was it.
Yeah, don't undo.
Yep.
Because like we share an undo buffer and
Yeah, it's like
VS
the
Code.
weirdest. I don't know why VS Code did that, but
Okay, well, unless that means I'm typing. Okay, accumulates outputs from X instance of oversize n, and not emits.
I guess we could check for consistency with lists, at least in cases where the list is a multiple of the chunk size. Okay. Nice. The test. I just wrote a test and it already failed. I think
Cool.
there's like a off by one.
Wait, what is this about take here?
Oh, this is where do you see take?
And on line 22?
You see take there?
Yep.
Weird.
Are we just out of sync because of that undo buffer issue?
Yeah. What about now?
I still see it. VS Code is so unreliable.
Weird.
I mean,
okay.
this collaboration stuff is not great.
How about
Actually,
now?
the editor is not updating. You're not updating for you. I mean,
okay.
your edits aren't showing up in my VS Code.
Okay.
Scroll to the top of chunk. Scroll to the top of chunk.
Mm-hmm.
Okay, so my edits show up in yours. I'm just gonna disconnect.
Okay, sounds good. I think there is. Yeah, I think there's there's sort of an off by one here. It's like line 14, that might make the buffer full, but it doesn't emit it until the next step with this current implementation.
Yeah.
Um, so I think we can just kind of, we could just do, we'd say match buff. I guess what if you pass in chunk 0? That doesn't make sense, does it? That's just an error. So
I mean, what I would expect is that it would just emit, empty lists.
yeah,
Yeah. So
just
consistent with
in
the
an in,
behavior. It's a buffer of size 0, and it emits it whenever it's full.
yeah, or I'd probably just throw an error like at call time. You probably don't want, you probably didn't mean to do that.
Maybe.
Or I don't know. Okay, so sorry. Let me fix. We'll figure that out in a sec. This is going to be buff, or sorry, this is going to be empty in buff, and otherwise it's going to be buff like that.
Yeah, that looks much more reasonable. Does the test pass? No.
It does not. Oh, but I didn't get to the property test is not correct yet. Let's just see if the basic example. Okay, the basic example passes.
Okay.
The property, which is checking for consistency with list.chunk, is going to be different because the last chunk might not be the same. Because like list chunk will emit a partial chunk at the end, right? What if we just take the first n-1 chunks? Those should all be the same, right? They should all be equal to the chunk size. Okay. How do we do that?
You could also multiply the size of the list with the chunk size. Make sure that it's evenly divisible.
Great. Let's do that.
There you go.
Let's say 25 here. Does that work? It does. Amazing. Okay. Cool. Okay. The only thing this doesn't do is if you pass in 0 for the chunk size, it's actually going to, just because of how this is written, it will, it's going to emit these singleton chunks. Like this would need special handling for the
okay.
I feel like it's probably an error. Almost never what you want, but that'd be like you're skipping all of the empty, or you're skipping all the outputs and you're just constantly emitting the empty list.
Yeah.
But maybe that's useful as a base case.
I mean, you could make that an equal sign there, and then the only case where the size would be bigger than the chunk size is if the chunk size were 0.
I see, but then it's going to keep accumulating into the buffer, which seems bad.
Oh, that does seem bad. No. You put another case.
Yeah. Okay, so we do equal, which is that's this case, and then we do greater, which is this case, right?
Yeah.
This will probably never come up, but all right.
I mean, we could also just skip that case and document. Say, if you provide a buffer, a chunk size of 0, it'll be treated as a 1.
Yeah.
It's just like, it's a waste of code to, like, on every iteration, you're checking, is this thing 0? Is it 0?
Yeah. Let's just do that. Let's just document it.
You could start by saying, is the chunk size 0? And if so, just output in a loop empty lists.
Oh,
You're not checking it on every iteration. Like up here.
Oh, I see.
You can say if chunk size equals 0, then
it's just input pipe to always.
Is it called always?
Empty. Yeah, it's called always empty list.
Always empty list. That's that.
Yeah. Oh, maybe always. Always, I think, is just. Does it not take an input? I think it's just. Yeah. No input. So just always. Yeah.
It's that? Oh, it makes sense.
Great. We need some examples in this doc, though.
Okay.
Maybe just crib this one, line 19.
Sure.
Cool. Are you working on an example?
Oh, sorry. I thought you were working on an example.
Oh, all right. I was waiting. Good. All right. Yeah.
I mean, the simple example is from the test, 928.
Yeah, we can just take that. Just do input to xf.chunk3 to doc.example. 3, 4, 5, 6. How's that look? xf.chunk. Wait.
Yeah.
No, could do singleton chunk. It's kind of it's always a good one. I guess we can do the 0.
Yeah.
I'm gonna move your if the chunk size is 0 to right above this example.
Oh, right. That makes sense. And then
Right.
I'm gonna make one more example, which is like when it's not evenly divisible.
Cool.
And I'll move that line too.
Yeah, it's like if it's applied to finite input and the size is not evenly divisible by k, then it won't emit a final chunk.
Yeah.
It's like it has the invariant that all the output will be of that chunk size.
Mm-hmm. Okay, so
Great. Oh, sorry. You're typing. Go ahead.
so, great.
Cool.
Yeah, that looks good.
All right. Let's add it. Ship it.
Ship it.
Great, man. I think this is a good stopping point. What do you think?
Yeah, agreed.
That was fun. Let me stop sharing. So what did we learn, folks? If you are watching this, we learned a little bit about using this library. Hopefully you got to see some of the development experience of writing some Unison code, writing docs, writing tests. And yeah, I don't know. That was fun. Join us again next time.
Thanks, Paul.
All right. Thanks, man. Catch you later.